What if your interviewer asked, so, once the data's stored, how does LangChain actually find what you're asking for, without hallucinating halfway through? What would you say? It's 2025, the economy's still unpredictable, engineers are learning to do double the work with half the caffeine, and even Fong systems are trying to retrieve efficiency like it's lost data. In times like these, precision matters more than power, and that's where the second half of the RAG workflow shines. Alright, let's explore the second part of the workflow. The second part of the workflow begins when the user submits a question about the stored content. For example, if the document is The Lord of the Rings and the user asks, what is the name of Frodo's sword? The system follows these steps. Step 1. Converting the question into an embedding. The question is converted into a vector embedding, just like the document chunks earlier. This ensures the system matches the meaning of the question, not just keywords, avoiding irrelevant results. Step 2. Retrieving relevant chunks. The retriever uses the question embedding to query the vector store for the most relevant chunks. The vector store returns the top matches ranked by similarity score, ensuring the most contextually relevant passages are selected. Step 3. Pairing the question with the chunks. The retrieved chunks are combined with the user's original question. This gives the language model both the query and the necessary context to answer accurately. Step 4. Generating the response. The language model uses the question and retrieved context to generate an informed answer, based on the relevant data instead of guessing. Why RAG is effective? This process is what makes retrieval augmented generation powerful. It allows language models to use external or private data to provide accurate, context-aware responses. What's next? The next step is to implement this workflow in code, demonstrating how the process works in practice.